In December 1939, as Europe was poised on the brink of war, two German radiochemists split the uranium atom in their Berlin laboratory. They confided the results to Lise Meitner and Otto Fritsch, who calculated the released energy at 200 million electron volts for one atom. The significance of the event was understood immediately in scientific communities in all nations. Virtually unlimited energy could be produced in a controlled reaction, and an uncontrolled reaction would yield an explosive of incredible power. The University of California at Berkeley was where plutonium-238, half-life 86 years, and plutonium-239, half-life 24,000 years, were first created. Seaborg, Segre, and McMillan used cyclotrons to produce 1 microgram of plutonium. After months of work, their product could be detected but was too small to be seen. Plutonium was described as a crazy metal. Small amounts spontaneously combust in air, so it must be handled in an oxygen-free environment. Depending on the chemical form, it might be blue, green, purple, yellow, red, brown, or pink. Seaborg said under some conditions it might be brittle like glass or soft like lead. It would disintegrate at room temperature, undergo 5 phase changes between room temperature and the melting point. It is fiendishly toxic even in small amounts. Robley Evans, who studied women exposed on the job to radium, wrote that as little as 2 micrograms, 2 millionths of a gram, was fatal. Ernest Lawrence told government officials that plutonium-239 could be used to make a super bomb. It was 1941, and the United States would be in the war in a matter of months. Albert Einstein, Leo Szilard, and Arthur Compton were instrumental in persuading FDR to study the feasibility of building a nuclear bomb. The Manhattan Project was a secret effort to build the atomic bomb. It was a gamble that represented several $billions and a significant percentage of the wartime budget. The Oak Ridge plant in Tennessee was 56,000 acres devoted to making uranium-235, and the Hanford, Washington site was devoted to making plutonium. These facilities had taken the bench-scale process and increased it a billionfold. General Leslie Groves was tapped to head the massive project. He appointed Robert Oppenheimer to be in charge of the design, construction, and testing of the weapon. Los Alamos, New Mexico was chosen as the site of the facility to build and test such a weapon. Quantum physics was a science that had been invented by 20-year-olds, and the staff Oppenheimer assembled for the Manhattan Project reflected that. The bomb might not work, and if the high explosive failed to ignite the fission reaction, $2.5 billion worth of plutonium would be scattered across the Jimenez Mountains. Jumbo was the largest fabricated object ever built, designed to contain the plutonium if ignition failed. At dawn on July 16, 1945, the Trinity site witnessed the detonation of the device codenamed Gadget. The remaining 2 devices, named Little Boy and Fat Man, were used on Hiroshima and Nagasaki on August 6th and 9th, killing approximately 200,000 people. World War II terror bombing of civilians began with the London Blitz, killing 30,000 people, and culminated in the firebombing of Dresden, Germany, and Tokyo. Napalm was used in 1,000 plane raids that incinerated approximately 200,000 people. The atomic bomb did not add to the scale of mass murder of civilian populations, but it certainly made it more efficient. Many of the scientists were appalled at the results. Some had urged a demonstration shot. They publicly declared that the U.S. possessed only a few years' head start before another nation followed suit. Many of the scientists and some of the generals advocated international control and the eventual banning of nuclear weapons. Those that tried to head off a nuclear arms race in the end failed as events and personalities took on a momentum of their own. Edward Teller advocated the Super Heavy, the hydrogen bomb. Oppenheimer objected to the development of the hydrogen bomb and stated that these were genocidal weapons. He was promptly replaced. Teller assumed the scientific leadership of the weapons program and remained influential for the entire Cold War. The largest hydrogen bomb ever tested by the U.S. was around 40 megatons, 4,000 times more powerful than the 10-kiloton Hiroshima bomb. The nuclear arms race that followed has resulted in the doctrine of MAD, mutually assured destruction. If either the U.S. or USSR launch any or all of their half of the 20,000 existing nuclear weapons they have aimed at each other, then they can rest assured that they too would be completely destroyed in a retaliatory strike. The nuclear arms race consumed much of the wealth of the U.S., leaving the civilian population living in the very real fear that the world could end in a matter of minutes. Nuclear weapons testing began in the Pacific and the continental United States. Residents of the Marshall Islands were forcibly relocated, and dozens of devices were tested there, some so enormous they obliterated large parts of the islands. Captured and obsolete ships were placed in the blast zone with test animals on board. After the detonations, thousands of observers and military moved near Ground Zero to decontaminate equipment. The military brass wanted to know how equipment and men would fare in a nuclear war. At what point are the ships too hot or the men too poisoned to continue to fight? The Air Force sent planes into radioactive clouds that registered 800 rad per hour or higher, adopting lead helmets and special shielding in an effort to protect the pilots. The Army placed troops in trenches 1,000 yards from the blast, and immediately after the explosion, walked them online through Ground Zero in an effort to prepare them psychologically for fighting with nuclear weapons. General James Cooney was the foremost advocate of testing and took authority away from the AEC, the Atomic Energy Commission, for the responsibility of setting exposure limits on troops. Scientists were allowed exposure of no more than 3.9 rad for a 13-week period, while limits for military personnel were officially set at 5 rad per test. The badges given to troops to wear measured only external beta radiation and were not used extensively. The scientists working for the AEC wore protective gear while the troops did not. The health effects of radiation were fairly well known to the scientists involved due to their animal studies, industrial accidents, and the very public death of Madame Curie and others. By the 1920s, it was known that hundreds of the early pioneers in radiation studies were dead. A single dose of 350 rad was the human LD-50, the dose that caused death to half those exposed. 1/1,000,000th of a gram, once inside the human body, could cause death. A nuclear explosion immediately produces alpha, beta, gamma, and X-ray radiation. Hundreds of different radioactive isotopic particles are formed as residual contamination that is absorbed into different body tissues with varying degrees of longevity and toxicity. One example is radioiodine that collects in the thyroid. This kaleidoscope of sources make it difficult to gauge what dose has been delivered and to what effect. The inhalation of a small particle of plutonium could collect in the bone and emit energies on the order of 200 million electron volts. The normal energy level of the human cell is 10 electron volts, and under such an assault the cell either dies, becomes inoperable, or grows uncontrollably, in other words, cancer.